That's right. All right, so we got to get moving on. This is the second part of the notes on alkanes, organic chemistry. And we got primary, secondary, tertiary, quaternary carbons. So these are different carbons can be called different things. So a primary carbon is going to be a carbon that is basically right there on the outside. It's exposed. It's got 3 hydrogens attached to it. That's going to be primary. Oh, it gives us a definition right there. All right. Carbon bonded to only one other carbon atom. So that's probably a better definition. That carbon is bonded to just one other carbon atom. So it's the end carbons. Secondary carbon is going to be a carbon that's connected to 2 carbon atoms. 1, 2, 1, 2. All right, and then tertiary. Any ideas what tertiary might be?
3 other carbons.
3 of them. So we got 1, 2, 3. And any, how about quaternary?
4.
There we go. A carbon connected to 4 other carbon atoms. Quaternary. So that's just, fancy language. You might have a question. This halogen group is connected to a primary carbon. Or if you're talking about SN1, SN2 reactions, you might use a secondary carbon versus a tertiary. Kind of vocab. All right, then we got isopropyl. So this is kind of slang. You might have heard it in isopropyl alcohol. It's just another way of saying it, and I'm going to write it. R is just everything else. So it could be like an ethane, it could be a propane, it could be a cyclohexane. R is just a carbon group. So, and when a carbon group has, I guess you could consider this a tertiary carbon with 2 methyl groups hanging off. That's the conformation of isopropyl, because we got 1, 2, 3, which is propane, and it's connecting to something on the secondary. Well, that was once the secondary carbon. So I guess iso is kind of coming from the center. Whereas isobutyl, we got an R group, and here we got 1, 2, 3, 4, and butane is 4 carbons. And then tert-butyl. Oh, there we go. Sorry about that. And it's butyl, so we got 4. 1, 2, 3, 4. And it's tert. I don't think you're going to see that on an IB exam, because it kind of veers away from your IUPAC naming, and IB focuses just on IUPAC naming. But have you seen isopropyl alcohol before?
Yeah.
Yeah, so that's why we're talking about it. So iso just means, it's coming from the center of a group of carbons, of a carbon chain, essentially. All right, moving on. We got an alkyl group. We already talked about this. It's basically a side chain composed of 1 or more carbon atoms attached to a carbon chain. It's derived from the corresponding alkane by removing 1 hydrogen. It is named by replacing the ane with il. Derived from methane is methyl, ethene is ethane. Okay, blah blah. Talked about that already. We talked about the numbers. We talked about prefixes for the alkyl groups, and we ordered them in alphabetical order. Our numbers are the lowest we can make them, and then the longest chain. All right. Hey, looks like we got some more practice. All right, practice, practice. So I'm going to put the pause on the video and give you some time to practice this. All right, so 2,4-dimethylpentane. I kind of heard, saw a lot of people got that for the first one. Questions on that? Okay, so this letter B is the tricky one. I had to even think about this a little bit. Because first off, we got an ethyl, and we got 2 methyls. 1, 2. So alphabetical order, we got ethyl versus methyl. Ethyl comes first, E. So no matter your numbering, so we got 1, 2, 3. Let's show this. 1, 2, 3. 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. We got 3 and 5. Okay, and we got 3 and 5. Oh, so tricky. So then there's two possible names for it. If you Googled either one, they would both give you, some images of the same line angle formula. So let's start with the bottom numbering first. We got 3 and 5. So it's going to be 3-ethyl, 5,5-dimethyl, and it's 1, 2, 3, 4, 5, 6, 7 heptane. So 3-ethyl, 5,5-dimethylpentane. Or we can go 5-ethyl, 3,3-dimethylheptane. So that one's kind of a little challenging one. And then the bottom two, I personally just write the line angle formula first, and then I write the structural formula. So 2,3-dimethylbutane, I got 1, 2, 3, 4, that's my butane. And I got 2 and 3. 1, 2, 3, and 4. So I got my methyls on a 2 and 3. And then drawing my condensed structural formula. I mean, this is what they're talking about. Some people kind of wrote it out with showing how it is like this, but showing the CH3, CH, and that's fine too. But we've got CH3, CH, and we got to put in parentheses the CH3 methyl group. And we got CH, and we got to put in parentheses the CH3 methyl group, and then we got CH3. Same thing with this one. We got 1, 2, 3, 4, 5 for pentane, and then 2, 3, 4 trimethyl. 1, 2, 3, 4 trimethyl. And then we write it all out. Questions on those? All right. So for the middle one, it says alkane naming with alkyl group examples. They're not written on the page. Go figure. So in hindsight, I guess I should probably write those out next time. So here they are. Here's some random examples. I got 2 names and I got 2 condensed structural formulas. So we just got to name it. N-hexane. N just stands for normal. So it's like saying hexane. All right. How do we draw that? Would it be 6 carbons next to each other? Yeah. Yeah, let's just do line angle. 1, 2, 3, 4, 5, 6. Or you can draw 6 carbons all kind of next to each other. I think that's 6. Yeah. How about 3-methylpentane? How many carbons? 5. 1, 2, 3, 4, 5. And the methyl is on which carbon? The third. 1, 2, 3. And it doesn't matter which way you count because it's symmetrical. All right. How about this one? We've got 1, 2, 3, 4, 5. So this is pentane. And the methyl group is on 2. So 2-methyl. Sorry. Yeah, these are supposed to be connected here. 2-methylpentane. All right, then this one would be what? 2,2-dimethyl, because there's 2 of them. And we've got 1, 2, 3, 4, so it's butane. 2,2-dimethyl butane. All right, and then below is just kind of a reminder on naming. Okay. Let's see what the next page has to offer. All right. Alkanes, writing isomers. Hey, this is kind of like that pink sheet that we did earlier. Constitutional isomers. Are there a lot of different types of isomers? Yes. We've only talked about constitutional isomers. Part 5 of this unit is optical isomers, which is more complex. We'll talk about that later. For C4H10 can be written by first writing the continuous chain, then remove one CH3 and attach it as a branch. Or it's like trial and error. 1, 2, 3, 4, 1, 2, 3, 4. We got 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10. All right, I think those are the only 2 isomers that can be written for butane. So let's do another example. Let's do C5H12 and name each. hint, there's 3 constitutional isomers. Do you want to do this one together, or?
Yes, please. Yeah.
Okay. So I'm going to go with the simple one, 5 carbons. All right. I'm going to go with my personal favorite in the line angle formula. 1, 2, 3, 4, 5. Just double checking there's 12 hydrogens. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know if it's a primary carbon, there's 3 hydrogens. Secondary carbons, there's 2 hydrogens. I know a primary carbon is a carbon attached to just 1 carbon. Secondary is attached to 2 carbons. All right. Nice. So that's the first one. And then what I'm going to do is 1, 2, 3, 4, 5. I'm going to just do trial and error. 1, 2, 3, 4. And probably pop a methyl group somewhere like right there. I can't find another isomer and put one there because this is symmetrical. If I flip it, then the methyl group would be there. So we got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So that's valid. So I'm going to try propane as my next one. And 3, but I got 2 more carbons, so I'm going to put 1 there and 1 there. All right, 3, 6, 9, 12, 0. There we go. So that's how I do it, just trial and error. I go with the longest chain. I then drop 1 off the longest chain and put it as a side group, alkyl group. And then I make it shorter and I find my isomers. You might have a better way. I don't know. All right. And we're at what, 15, 25?
20.
20, okay. I was around there. Haloalkanes is just that. It's an alkane with a halogen attached. So we're adding layers. And I'm in the process of making a card game based off of functional groups. So yeah, kind of like euchre, but I still have to develop the name of it. But when I retire, I'll probably make it. So. Because there's different functional groups that trump other functional groups in terms of naming the end of it. So that's where the card game comes in. But, all right, so
yeah.
There you go. Yeah. So. All right, what does this say? It says, hey, I'm going to need one of those people chatting in the back. Like, Dobson's not here. Okay. Any volunteers? Oh. Okay. Do you want me to do it? Oh, Ryan, thanks for volunteering. All right. Yeah, I'm having trouble reading this. What does that say?
Or hydrogen atoms in an alkane is replaced by a
Thank you. It's a tricky sentence. It's hard. All right. So basically, you got a halogen instead of a hydrogen. Simple haloalkanes are named alkyl halides. All right. Fancy. That's like an HCl type deal. In IUPAC names, a halogen is named as fluoro, chloro, bromo, or iodo. There we go. And hey, we only deal with 4 of them because there's 4 halogens: fluorine, chlorine, bromine, and iodine. Oh, it looks like these are just kind of written examples. Here we got the molecular formula, condensed structural formula, and here's the name. There's some non-IUPAC name. We don't have to worry about that. Here you got the butyl and stuff. So we got bromomethane, also known as methyl bromide. Oh, no, we got to write that out. Yeah, let's write that out. Bromomethane. Well, it's kind of hard to write in line angle formula, but you can, because we got bromine. It would be simply like that if you're doing a line angle formula. But since it's so small, typically you just write it all out. There we go. Bromomethane. And it goes in alphabetical order. So... all right, so here we got 2-chlorobutane. Looks like they wrote it out for us right here. 2-chloro, 1, 2, 3, 4, butane. Oh, but what if you got 2 or more substituents are named in alphabetical order? So we got chloro and bromo. I think B comes first, and we got 1, 2, 3. Let's count this. 1, 2, 3, 4, 5, 6. Oh. All right, so we got 2 and 5. Oh, and 3 and 4. So what's 4 plus 2? That's 6. 5 plus 3 is 8. Looks like... Wait, did I count it wrong?
Yeah.
Oh my gosh. Oh! Wait. No, I'm comparing these. 5 and 3.
I'm just wondering why they have...
Oh, maybe they're wrong.
Yeah.
All right, let's look at that. Because technically it should be this one. Oh no, they did it right. 2 chloro, and then 4 bromo. So that's correct. Why is 4 before 2? Because the order is based off of the alphabet and not the number system.
Never mind, I was confused about the picture.
Oh, this one?
Yeah.
Oh.
I'm sorry.
No problem. No problem. All right, yeah. So we got 4 bromo, 2 chloro, 1, 2, 3, 4, 5, 6 hexane. 4 bromo, 2 chlorohexane. Nice. All right. So that brings us to the haloalkene practice time.
No.
Then we got cycloalkanes, and then after that, tomorrow we're going to have the fun of doing alkenes. Last year I made the mistake of giving the first quiz without talking about alkenes and alkynes, and then remembering, oh yeah, there's alkenes and alkynes on the quiz. Not going to make that mistake again. So if we need to push the quiz back a day, we can do that. All right, take some time. Here are the answers. You can take a look. Letter C actually has 2 possible answers because the numbers are going to be the lowest no matter which way you go. D is going to be tricky. We're looking at this. Fluorine, there's 3 of them. Bromo and chloro, there's just 2. So the fluorine you're going to want to have on the first carbon to have the lowest number. Because you got 1, 2, 3, 4, 5, 6, 7 versus 2, 4, 6, 7, 8. So the lowest number. So fluorine has to be 1. Yep.
Will we get docked on the test if you don't put in alphabetical order?
Yes.
Alright.
So, oh shoot, we got to do alphabetical order. Okay, bromo comes first. All right, so 2 bromo, 2 chloro, 1, 1, 1, and there's 3 of them. Try. I would put the 1 down. Yeah. Well, you could probably get away with not because, yeah, fluoro. What is this? Ethane. And that's that.